Hi, and welcome to the first live streaming of Cratis related stuff, what we kind of really, well, talk about as the Cratis Stack. My name is Einar, and together with Sindre, say hi, uh, we're going to present today basically everything based off of event modeling and off of the book from Martin Dilger and the Understanding Event Sourcing book. And basically, this will be our take on how this all works, or how you can do this with the Cratis stack. So, but before we get started, we need to set a little bit of context and, well, explain a little bit what Cratis is and what it does, and also maybe a little bit of a kind of a peek into where we're coming from with this. So our journey, or my journey, started actually back in 2009 when it comes to event sourcing. And I was working at a place called Komplett here in Norway, which is basically, well, it's one of the largest e-commerce in Norway. So we saw the kind of the benefits of actually doing event sourcing. And at the time, there was a lot of talk in the community, well, like CQRS, event sourcing, DDD, and all these kind of things. And we basically applied everything, and we open sourced everything that we did into this thing called Bifrost, and that's kind of the starting point of well, my journey at least on this topic. So we were lucky enough to actually kind of maintain this at work and also be able to go to another, well, at that time, a customer, being consultants, being allowed to actually continue the development of this at um, a company called Statoil at the time, a oil company here in Norway. And we basically were able to actually evolve every thought we had into this. And in 2017, we were also able to get funding to start a company to actually start focusing around this. And this is where I met Sindre. And we started, well, he started at our company and got to know all of our stuff at that time. And this became a little bit different, but we modernized everything and all the concepts and took it further. And in 2021, I started at a different place, a insurance software company, and basically came up with Cratis, and this is kind of the inception of it. And it is much more focused on kind of the developer's story, much more focused on, well, making it a lot easier, much more flexible than what was before. And again, all open sourced, of course. So let's dive a little bit into what Cratis is. So basically, if you go to GitHub, you'll find an organization called Cratis, and you'll see that we have a few different projects there. And these are kind of the main projects that we maintain. And these are the kind of the purpose of them are at the lowest level, we have a thing called specifications, which is basically the our take on how to do specification by example as a thin little wrapper for X unit or N unit. And basically allowing us to express specifications BDD style. Uh, so that is kind of a foundation thing that we use all over the place. And we have this fundamentals project, which is basically a library with kind of generic building blocks. It can be helpers, it can be reusable stuff for just about everything. And I like to see it as kind of, okay, the things that we feel is missing from the base class libraries of .NET typically. And you'll find that we also have fundamentals for TypeScript or JavaScript as well in that same project. So we've added stuff that feel is needed. And on top of that, there's this application model, which is basically geared towards well, productivity. Take be a little bit more, I would say, uh, take some concepts and actually formalize it like CQRS and all these different things and be opinionated about these things. So it's a more opinionated approach to application development. But again, built around like .NET, and also here we have client libraries for front end stuff. We have React support and things like this. So Then, separate to all of this, we have Chronicle, which is just a an event sourcing type of database, if you will. It's built on top of MongoDB today, but and with client libraries. These client libraries are not that opinionated when it comes to, well, all these automatic things that the application model is doing. So you can basically take Chronicle and work with it on your own. You can also take the application model if you just want that and not Chronicle and all that. So it's very flexible in that regard. But what we tend to promote with these things when we actually put everything together is this pipeline thinking. So we have basically two types of pipelines. We have a command and a query pipeline, and we think of commands as the, well, it's the thing that the user wants to do. So it represents the intention of the user, and that ultimately with Chronicle being part of this will end up in an event or one or more events. These events are then appended to an event sequence. The default event sequence that we have is the event log. You would then typically have so that event log exists in the event store. And you would typically then have an observer that observes these events as they happen and then turn that into, well, it can turn it into a read model, but it can also turn it into, well, send an email or react to it and perform other actions. So, but we, when we started designing Cratis, we were kind of thinking a lot of the problems that we saw in the past was that there's a lot of context, there's a lot of concepts that a lot of people associate with typical CQRS and event sourcing. Yeah, and you tend to kind of bring in domain-driven design, and you have these concepts of aggregate routes and all that. And what we did actually early on was what is known today as the dynamic consistency model, a phrase coined by Exonic. No, yes, boundaries. Yes, sorry, and that is a concept that we kind of had from the get-go. And the point of it is that you don't always need an aggregate, but you should be able to produce events. But you need other constructs to maybe guard your domain a little bit. So the typical thing, the role of an aggregate is to guard your domain and be the thing that actually has the last say before an event is produced. So we have things like rules. We have a construct called rules for. So you can basically tell it, so construct your rules for the specific command, and that can be your guard, basically. And then your APIs or whatever can still just produce events directly to the event log or to the event sequence. But we also have, of course, aggregate root. And when it comes to the observers, we have basically three different types of observers that we talk about. We talk about reactors, reducers, and projections. And all these have different characteristics, and they're kind of, you pick the tool that fits the job, basically. And to dive a little bit into what they are, so if you look at reactors, they are kind of the most flexible things because it's basically just an if this and that. You can do whatever you want with these. You can produce a read model, you can send an email, you can send a text message, whatever. You can do basically anything with it. While a reducer is much more opinionated because it's actually meant to be producing these read model states. And that means also they're partially managed, and they're different from reactors. You typically wouldn't use a reducer to send an email. It actually produces state. So while on the full far right side, we have projections, which is fully managed, which is just a declarative way of defining a map reduce. So I want these events and I want you to produce this state. You can basically kind of compare it to I think, materialized views in a typical relational database. So these three constructs are kind of important, and we're going to be, at least we're going to touch on the far right today. We're going to start on the projection side, and then see how far we get. So we've kind of scheduled this for, well, up to 1.5 hours today. So at, well, my time 9:30. We'll see how much we get to fit into that time slot. So we mentioned something about event modeling, and I think this is a cue for you, Sindre, to take us.
Yes, I'll take the cue. So I will not do this justice in a way, since there are lots of good resources to look up to get to know this event modeling and how to use it effectively in your products and projects. But the cool thing is that event modeling is really easy to explain. It is a term coined by Adam Dimitruk, and what it is in its essentialness is that it's just a collaborative process of describing an information system, and it builds on a few building blocks, which are the event and the command, which is an intent or an action that produces an event, and the read model, which is some state that you can materialize from events. And so if you have done event storming before, all of this on the event model will probably be really familiar to you. But one of the things that event modeling has done is that it has formalized a couple of patterns, so that you can use that to build the event model. And those patterns are basically the state change pattern, where you have a command that produces an event, and some sort of usually a user action or another system that interacts with your system. And you have the state view pattern, which is that events, they compromise the data that will be shown to a user, or data that can be transferred to another system for calculation or processing or whatever. And you have the automation pattern, which is what I just mentioned now. So data sent over to another process for processing, and it can come back to your system and have some intent or effect on your system, again producing events or read models or all other things. And the fourth pattern is the translation pattern, where you usually have something like an event or an external event coming from external systems, and it being translated into an event in your system. So and from domain-driven design, this is the anti-corruption layer typically. So and so we'll be trying to follow along with the first slices of this event model that comes from Martin Dilger's book, Understanding Eventsourcing. So you can do you want to scroll down to the event model?
Yes.
Yeah.
So, yeah, do you want to walk us through this?
Yeah.
How this
So
works?
yeah, so here is one of the things that you probably won't see in an event storming, or the result from an event storming, and which is quite particular with the event model, is that it also includes UI and UX directly into the event model, and that is really deliberate, because humans, they learn and remember a lot better on visual cues. So having that integrated into the event model is a really good way to for people to be quickly onboarded on what the system is actually doing and how things are interacting with the system. So here you see there is a vertical lane here, which is we call it a slice. And for this domain is basically like an e-commerce kind of domain. And this first slice represents the adding of an item to a cart. So you'll see the blue post-it. Again, in event modeling, we kind of have decided on a few colors that represents the different building blocks. So blue usually is the command, and you'll see it by the name of it, and it also has data on it. And the result of a command is an event or multiple events in this case. So we have a cart created and an item added. So the cart created, we'll see that below later on. But the cart created the event usually is the first event to come from this command if the cart hasn't been created before. And if it has been created, it will just add an item, so item added. So, yeah.
Yeah.
And there are more slices to this event model, but I think we'll be focusing first on the first one, and also on the given when thens for that slice. So that is also a thing that has been kind of formalized into the event model. The specifications that kind of describe more of the behavior of a slice in terms of rules and another kind of things that are particular to slices. For instance, in this case, we only allow for 3 items to be added to a cart, and that can be really easily visually represented here. We call it the given when thens, because we have given is the information that is needed for in the system in order to get to the state that we want before we want to do the action that we want to have, that we want to check the effect on. So in this case, we have a cart that is created, and we have 3 items added to that cart. And when we add an item, it should throw an error, or it should be an error case, or whatever you want to do in your system. So yeah, it's a really cool way of having the intent in the system easily visualized. Or yeah.
Cool. Does that mean we are good to start kind of hammering out some code for this?
Yeah, that should be the good thing from this, is that we should be able to translate this pretty easily into Cratis code.
Yeah. Okay. Should we just take it away then?
Yeah, do that.
So what we have prepared beforehand is basically just a scaffolded project, which gives us a way to actually implement these slices in a good way. So this is a scaffolded project with both a backend and also the front end sitting here. And the way we tend to want to do these things is actually we when we talk about these vertical slices, we actually talk about high cohesion with all the code being in one place. That means that we will, as you see, while we develop this, we actually keep the front end code together with the back end code. So if I start by thinking, okay, I have this features folder here, and we are now talking about the cart. So if we go back to the this place, it's actually kind of the context of the cart, right? So we're working on the cart part. What we tend to do is basically also pluralize them in the folder structure. So we're talking about the carts, and everything related to carts goes here. And what we wanted to work on is the slice that is basically the add item slice. So I go and create a add item folder for that. And within this, we actually then can start creating like, okay, add item to cart. I like to actually append this information so that we know what this actually is. And you'll see why in a little bit. So what we can then do is we can create eCommerce features, and then carts, and then add item. Yeah. and then create a record, which is then basically add item to cart. And what we want to, at this point in time, actually start looking at is like, okay, it has some properties in here that it's kind of want to actually have. So uh, we're going to skip a few of these because I don't think they make sense in a way in a kind of e-commerce. And for this, I wouldn't. We don't need the description. We don't need the image, and I think we can kind of combine these item IDs and product ID into what in e-commerce is called a SKU, stock keeping unit. So we're basically looking at like, okay, price and a SKU at this point. The aggregate ID will be, you'll see how we actually use that and how we use that with typically Cratis Chronicle. One of the things that we like to do when we work with these things is that, okay, you looked at the types over here. You see it's a UID, it's a string, it's a string, it's a double, and all that. What we want to do is formalize them into what we call concepts. We're not too fond of primitive types. So typical, like a price could be like a decimal, right? That would be the price. But we instead want to actually formalize that into a price type. Same goes for what is a cart ID, what is description, and all this, the other things that we saw. We want to formalize that into what we call concepts. And the benefit of this is that we don't have to be your APIs becomes more clearer. Everything that you work with is much clearer for what they are. You also get an opportunity doing cross-cutting concerns. Like we have support for in the application model, create this application model. You have the support for doing validation for types of that are basically parts of these like commands like this. So you could then have automatic validation for types. So if you for instance, cart ID, you could have a validation saying, well, it has to be a valid cart ID. And every command that actually has cart ID on it will run that validator automatically. So you get some cross-cutting concern uh, possibilities as well. And it's basically metadata. So you're adding metadata to your domain model, making it much more richer. So what I want to do then is go ahead and do just that. I'm going to do that right now in this file. So what we then do is, okay, let's do price, right? So that's going to be, it's still going to be the primitive, well, value that we're actually going to be working with is still going to be a decimal. But we encapsulate it like this, and we say decimal, and our AI almost got it right. And we extract that so out, and I actually want to move it up. So I want to have this available to more slices like this. And we probably also want to have something similar for a cart ID, something that represents a, cart. And we do that, we make a GUID. And we basically, could probably use the AI would have done this faster, right? So we have a cart ID and we have a price, and we have these two concepts here. And the last one I want to mention is also the SKU. So I mentioned that we want to kind of take the item ID and product ID and make that into a SKU instead of, right? So and Sindra is doing that.
Yeah,
While
I don't have the AI.
While he's doing that, I will extract that. So what I can now do is start using these things. So add item to cart. We want to have the SKU that we just did. So like that. We want to have the price coming in here. And I see that I've done something to screw up this. Let me just do this. It's the namespace, right? So that they're actually consistent. So with this now, we basically have our command, right? And what you'll see now is, so I can separate that out into a file like this. And hopefully this should build. So we can see, take a look and see if it's actually building. And if it does, so it is actually building now. So the next thing we want to do, so one of the design choices we made early on with the Cratis application model is actually not to go in and create our, well, kind of a command pipeline per se ourselves. It is something that we will be adding our own little command pipeline. But right now, one of the things that we got kind of pushback for is that from developers is that you have to learn a lot of new things. So instead of having to learn a lot of new things, what we decided to is actually make use of ASP.NET Core already. So for creating a command handler, something that actually can deal with this command, we can just go and create a controller, basically. So what we can then do is create an item to cart handler, and just basically do a controller base like this. And what we can then do on this is just have a controller action. So call it item to cart, and then do like we can do from body and add item to cart command, right? And you would then do HTTP post like so. Task completed. So I think you need to actually have it prefixed like that. So what happens now when I build this is one of the tricks that the application model has, if we can just get everything correct. Let me see what's it's complete. Ah, yeah, we have a thing. Okay. So the application model has this one trick up its sleeve, which is basically not doing its job. Where did it go? Again? Aha. I see. I knew I did something wrong. I'm going to have to fix this. Leave out that features in the namespace. This is a configuration thing that I have done wrong, but let me show you. So basically this, and this should now be in the same place. Because what happens now is that it will actually generate TypeScript code for me, right? So that item, add item to cart, now is a TypeScript component, which is a command. As you can see, this is how it implements that. It uses the command from Cratis applications package, and it generates a command that can be used directly in the front end. So you don't need to be calling, like using fetch to call the API directly. You actually get a programmatic model, and it also generates all the types. So like we see here, it understands the concepts and understands that the underlying type is actually a string, and the underlying type here is a number. So we'll actually generate that correctly for you. And this is super easy then to use in the front end. So with this, we basically now have the starting point of this whole thing, actually. So, but we want to produce an event. So I mentioned we have this basically the support for not having to use an aggregate. You can do this by quite easily just having the event log readily available here as a dependency. So that means you can actually call the event log and call append, and yeah, basically from the request. By the way, we want to have another thing here that we want to do is we want to have the cart ID here, but we want to have it as part coming from, as you can see, from the route here as Sindre put in. And what we're using here is a from request. This is also from the application model that gives us a way to use this, well, encapsulate everything in an object and not have it say from route here, which makes it easier to do validation and makes it easier to be also creating business rules. So once we have this, we can actually go and do command and we can do cart ID. And what we then need is just basically an event. So what we can do now is create the event for this, which is then item added to cart with that to cart, like so. And we can separate that out like this. And we can do new item added to cart. And actually, we don't need the cart ID on this. And the reason for that is that the cart ID is actually used as, if you can see, the first argument on the append is the event source ID. So this is the source of the event. And this is then the cart ID. You can look at it as the unique identifier for the object that you're working on. So we are now appending to the cart. And which cart? Well, this particular cart. And we're appending this event to it. So what we then need to do is we're getting some squigglies here. Is that because my Visual Studio is out of sync? Cannot convert. Oh, yeah. And that makes sense because we don't have an event source ID converter here. So, well, you don't necessarily need this. Event source ID is actually represented as a string. So what you can then do is automatically convert it since this is being used for that purpose, right? Then it's automatic there. So this is one way of doing this. We can certainly, do we want to try this, Sindre?
No,
No, we just want to talk about it.
too scary.
Too scary to try. So let's make sure that it actually builds and we can, our watcher here, restart the watcher. And yeah, we're missing one thing. We're missing one vital thing. Yeah, you put it in. Thank you.
Yes,
The
live
event
coding.
type. So event type is an attribute you need to put on these things. And the reason for that is that the Cratis or Chronicle will discover all your event types and register them with the server. And now that we have this, we can actually go and take a look in one of the things that comes with Chronicle is the workbench. So in the workbench, you can actually go and see the different things that you have. So you can see the events. So you can see that the event has already been registered, even though we're not using it. And you can see that we have the properties on it, SKU and price, and what types they are. And these are already now registered here. Inside the workbench, you'll see later when we start actually appending events, you can see the events coming in here. You can see the different types of observers. And if you have any failures for the observers, you can see those things and any identities because there is metadata associated with all the events that we append, and identity is one of them. And there's also this concept of a namespace, which is basically multi-tenancy. So you can use this for multi-tenancy. So let's say you want to keep data segregation between multiple tenants, you can have multiple namespaces. So that's kind of just a brief walkthrough of what actually is here. So if we go back to this place now and we look at the add item to cart, so we can actually we can do a postman thing, right? So we can do a new request where we do a post and we said it's what was it? Localhost 5000, right? API. And did we call it carts?
Yeah.
Carts, yeah.
API cards.
And
ID.
a GUID, so empty for now. And it was
Items.
Yes. Okay, so append items there. And body raw JSON. And we said SKU. So 1, 2, 3, 4. And a price. And the price is always 42 for obvious reasons. We should be able to now fire this away. And what we will get back is actually also a little bit different. This is something that is produced by the application model. So it will always return what is known as a command result when we are dealing with commands. And this will contain information about whether or not it was successful or not, but it's more fine-grained than your default kind of out-of-the-box ASP.NET type of result, because it will tell you whether or not it was authorized, is it valid, did it have any exceptions. And it will contain so validation results will be validation results, and you can have exception messages and also the stack trace if you want. So that should now be in our little thing here. And there it is. We have an event, sequence number of 0. It's the first event that we append to this. And if you click it, we will be able to look at the details of that event. So we'll see, obviously, the properties in the content, but in the context, you'll see, okay, we don't have identity hooked up here. So cost by, which is the identity, will be not set, right? So we don't have any logged in user at this point in time. Another thing that goes with this is also the causation. So causation is basically tracking where is it coming from. So the last thing that we saw was basically the ASP.NET request. So you'll see the route that happened and details about it, what host it was on, protocol, and all these different things. But you can have multiple causations. So this is kind of a hierarchy in a way. So that was the last thing we saw. The first thing we saw, which is always the root, will be details about the process and the runtime environment. So this will be that was the process that started this. What was the version of the software and what operating system and things like this. So you get a lot of these automatically detailed kind of things hooked up for you, but you can also extend on these causations if you want to. So I think that's kind of, that's showing the easiest way that could possibly work with adding an item to a cart. I also want to just quickly, because since this is Mongo underneath the covers, you can easily go to something like Compass or whatever Mongo tool you're using. You can see the same things here. So it should be fairly easy to actually understand what's really going on. You can see the event log, pretty neat, and it's understandable. You can expand on these and you'll see the same data inside here as well. And yeah, so the namespaces are here and everything, all these different things. You'll see the schema is a regular JSON schema for the event types being registered here. So with that, I guess we can kick it up a notch. Would you say? Do you agree, Sindre?
Yeah, let's do that.
Should we create, well, should we just create a rule first
Yeah, I think that makes sense.
before we create an aggregate? So let's just leave it like this and create a rule.
Yeah.
So if we go back to the event model, one of the things that it had, we're going to come back to this cart created thing, by the way. But it has a rule. If we look at the specifications, it said add item max 3 items. You can't have more than 3 items. So if we already have 3 items, there should be, well, the fourth should be a failure. So let's create a rule for that.
Know what we also could do instead? We could translate the given when then to a specification first.
To see that it fails. Ooh.
Yeah.
Yeah. See that it actually, yeah, we could do that. Okay. We're dynamic. A dynamic duo. So what we have also prepared is a project called specs.specs. So again, we just basically do a thing like this, carts. And what we can then do is let's create a folder saying when adding items to cart. Is that fair?
Yeah.
And then we can go and do something like, and there are already 3 items in the cart. So that's a scenario that we want to create. E-commerce, and then carts, and actually we forgot something. So this is for the add item vertical slice, right? So we can move that into there. I see you have a folder going there. So let's just go into this place and start this and folder saying with adding items to cart. And then a class, and there are, wow, that's so wrong. So what we have basically is a way of creating kind of these contexts. So we typically have a context in here that we want to, well, how should I explain this? So the type of test that we're actually going to build now is a typical an integration type of specification. So that means we actually have the database there, and what we want to do is like test an end-to-end scenario where we call the API and we actually then get data out the other end. We can check if the event was actually appended and all that, and yeah, go from there basically. So what we can then do is create a context here, and it will need to be the integration context like that. And we'll have so we're using XUnit. So what's it called? Do you remember this, Sindre? I have forgotten.
Yes.
Constants. Is it constants?
No. Global collection name.
Yes. Thank you. Thank you. And to kind of make this a little bit easier on us, we will do this. so that we can just make it a little bit more readable given a context. And we will have the actual, as Sindre has started on here,
Yeah,
an
I
empty.
think live share. Yeah, live share is a bit bad. I did actually write the class, but now it's empty.
Okay, so I will fix it. An empty cart. And we already have a base class that we want to actually leverage. So we've created a base class called a client, which is just giving us a couple of simple tasks or simple helpers that allows us to work with the HTTP client and also be able to get like a model, read model, basically. So what I want to do then is just inherit from that. Let me see, a client. It's complaining a lot. The VS Code. So what you tend to do is, and this is now entering kind of what the Cratis specifications stuff supports, is this concept of, so we're working with these different contexts. So when you have a given statement saying, given an empty cart, that's a context. And what you can then do is inside a context like that, you can actually establish it. So what we are doing right now in this class is create a very specific context for this class, but it inherits a context called an empty cart. Within every context, you can do establish, and eventually you'll also, for our scenario here, we'll also end up doing a because that's the thing that we're going to do. That's the action. That's the, for this scenario, where it's going to be the calling of the API. And what we want to do then is basically assert against different things after we've established a context and we've done a thing. And yeah, we can actually then start asserting against, like, okay, did it actually fail? Because that's the thing that we're creating right now. We're trying to create something that shows you well, a rule that we will be implementing that says you can't have more than three items in your cart. So how are you doing, Mr. Sindra?
I think it's ready to be set up. There's some obviously some issues with the live share. It's not behaving well all the time.
Yeah, and I keep getting these pop-ups saying something is completely wrong. But
Yeah, we should try continue, see what happens.
yeah, I'm just going to let you go with that. So what we're actually doing now is on the context, we're going to expose a few properties that we're going to be using in. So the context is an inner class to this specification, and we're going to expose a few things that we will be using in the assertions of the actual test class. So on this, we will have some XUnit facts saying should fail, right? So we're expecting the response to have a, well, be, what's it called? So it should be not successful.
Yeah.
And I think we've put a little bit here. Like so. The observer is something that we will be getting here. So we'll actually go and get projection, but we don't have that yet. So let's not just, let's just keep that there. And we'll add this when we have the observer for this, when we have a projection for this. Yes. So what are you adding now, Sindre?
Oh, no, there are actually no other things that we want to check. We just want to check that the response is failed.
Yeah, but we do need to call the API. So there is a HTTP client here. And how do you do that? You do like a post as JSON?
Yes, post as JS. Yes, I think it's that one. And then it takes the route and the command.
So
This
what
is
we're actually, sorry.
this is something that we can improve, so if we need to give it the JSON serializer options at the end.
Yeah, this is a globals that we have that basically gives you the correct serializer, basically supporting all the concepts and all these kind of things
Yeah.
out of the box. So yeah, so with that, we should be able to hopefully build this.
Hopefully
Please.
build, and then even more hopefully it will do what we want.
Yeah, it's spewing out a bunch of different warnings, but nothing anything. So context, there's a what? There's a property. Okay.
Oh,
Do you see? Oh yeah, of course. Yeah, my bad. Okay. Should this now actually fail? That's the question. Uh, let's see. Yes, which is good. It fails. That's good. That's a good start. So that means if we were to now implement well, first of all, we actually don't add the three items. So one of the things that we can do is we can go to the event store and we can go to the event log and we can append a few of these events like so. So that's now we're actually populating the event store with three items, three events before we get to this. This is kind of the scenario that we want to do. And we, of course, have to make that async. So do this. And that should really be the scenario, but it will still fail. And what we want to then do is go and implement the rule. So what we can then, for making a rule like this, we can do an item to cart rules and inherit what's called a rules for. And it takes two generic parameters. The first one is the actual rule itself, because you kind of need state for these different things, and it needs to hold that state somewhere. And what we do with this is basically hold the state inside the rule itself. So what you give it basically the rules, or add item to cart rules, and then you say what commands add item to cart. So once you have this, add item to cart rules, we can do, it's very confusing with the whole LLM doing a lot of stuff here. Uh, the rules stuff is built on top of Fluent validation. So you'll see kind of the similar type of concepts from there. But what we want to have is a thing that actually counts the number of items. And it does need to have an initializer like that. And on the rules for to actually be able to define the state, there is a thing called define state, which you can then override. And this is where the projection engine comes in. The first time we see the projection engine. So what we can do with this is actually go and say, from the item added to cart, we want you to go and do a count. So we want to count, and we want you to have the result inside the number of items. So what Sindre is now doing is building the actual rule for it. So what I did is just represent the state that we need. And this is important. This is an important concept when you're actually dealing with like CQRS and event sourcing, because you basically have two different consistency models. You have the command side is what we call the strong consistency model. That's where we want to have all, so that's the thing that you can rely on. While the read models are eventual consistent because they're completely asynchronously constructed. So that means if you're doing some sort of validation, some sort of rules for kind of protecting your domain and protecting your data integrity, you can't rely on the read model to do that because the read model will be eventual consistency. So let's say you, for instance, are registering users and you need unique usernames. You can't rely on the read model for that because, well, it could be milliseconds off, and worst case scenario could actually be the whole thing could take a little bit more time. So it's actually very important that you rely on the right side, the events, to actually create or have these rules, right? So that's why we have this construct rules for. And what rules for does is basically give you a way to define the state that you typically want to have checked. So what we're building up here is just a rule that actually checks the count and makes sure that we have the number of items as a state that we can use then the Fluent validation thing on top of. So with that, this should build, and we should be able to go back to our specification and hopefully see a green light, green bulb. That's what we're aiming for here. And sure enough, it is actually now successful. So that means our rule is now working, and yeah, everything is perfectly fine. So the next thing that we typically want to be doing is, I'm not going to jump to the aggregate just yet. I think we can start looking at the read side of this. So if we go back to the event model, so what we basically now did is this. We have we don't have the cart created just yet. We'll get to that when we get to the aggregate. So we have at least the item added as a given, as a context. We're doing the add item, and we're seeing the error happening. But if we go up this slice, we'll see that from the add item, we had the item added, and that should go into something for display purposes, a read model. So let's dive into that, how we actually
And
do
that,
that. So we can create now a folder. So let's say we call that contents. And we're talking about now the cart contents. Inside this, we'll have a cart, namespace, eCommerce, carts, contents. And we can then have a record, a cart like this. We can have a cart ID, and we'll have cart item on it. We can even have, as we can see on the model itself, there's also this concept of a total price. So we'll add a property for the cart itself, which will be a price, and it's going to be the total price. So what we now have is a read model, and the read model has a couple of properties and also a bunch of children, basically. So what we want to then do is create a projection that turns this into something that is materialized inside the database. And this is an interface. This is the interface you need to implement when you want to create a projection. It's iProjection 4 and the read model that you want to implement it for. So, and again, as we saw in the rule, it's kind of the similar syntax. You'll see that you have a defined state here, and you get an iProjection builder 4. Similar here, you get a define and iProjection builder 4. So you got the same projection engine working for you. So for us, that would be if we want to just we have this thing called auto map. That means all the different properties that are has the same name on the event as it has on the read model will be automatically just matched up. So you don't have to do like a specific map kind of thing between the different properties. So what we can do now is just go and say from or let's do the children. We want to do the children, and we need to point it to what property is actually representing the children. So that's the first argument to the children builder. We say, well, it's the items. Well, how do you want to do that? So it's the let's call it the children builder like this, and we can do children builder. And by the way, automap is completely recursive. So if you want to use automapping, you can do it on the top level. But you can also just, if you want automapping for a specific part of your projection, you can also do just that. But we have it on the top, so we don't need to do anything more than just this. And that should basically be it. But we also want to summarize into that total price thing that we did. So what we can do with the projection engine is also say from at the top level, we can say from item added to cart, we can go and do a like this. We can do add. Add is a function of projections. So you can go and do, okay, add what? I want to add to the total price, and I want you to get that from the event's price. So basically what this is saying, add total price with whatever the event has as price. Okay. And while I was doing that, Sindre has done something else. He has actually implemented a query. Again, it's completely, you can see this is regular controller. We're missing one thing, and that is the HTTP GET. And the way this whole thing works, and this is something that I kind of glossed over when talking about this, the way the kind of application model is recognizing the commands from the queries is by convention. It's just thinking HTTP post, that's a command. HTTP get, that's a query. So what we've now done is basically have in our API, we now have a slash API slash carts and then the cart ID, and this will give us the cart. One thing to notice here is that we are returning iSubject. iSubject comes from reactive extensions. So what that means is that this will turn into an observable query. And the significance of that is if you're calling this from a regular, like let's say from curl, it would actually be a streaming JSON. So it's like a long polling thing. It will just be returning whenever there are changes, it will actually return that data, that cart again as it changes. But if you go from the client perspective and actually connect to it using WebSockets, it will turn this into a WebSockets connection. So what we've done is just instead of using things like SignalR or other things, we basically just created a small little middleware for ASP.NET to automatically let you just create your APIs as you are familiar with and let you, well, take advantage of being more reactive in a way. And we
Yeah.
have for Mongo in this particular case, we have the Mongo collection. You can just take it as a dependency like this. And you can do an extension method on the collection, say observe by ID. And we give it the ID like this. So with that, if we now build, and hopefully it does build,
Hmm.
we'll see again, our little proxy generator did some magic here. It generated some TypeScript code for us. It generated the cart, and you'll see that's how that looks like. It adds some metadata for, we have a custom serializer. And the reason we have that is for you to be able to see the actual type in the front end. So if you were to debug this in your browser, you'll see that cart is an actual thing with the correct types on it. So we add all that metadata in there so that we can actually generate and deserialize into the proper types when we do this. So it's not just a JSON blob of things. So you'll see that for the cart and the cart item. And there's also what Sindre put in. He said get cart. So the name of the method here is significant for the proxy generator. So get cart becomes the name of the query. And again, as you saw with the command, it generates a proxy that can be used directly in the front end. And as you can see, it recognizes that it's an observable query. The APIs are slightly different because an observable query you typically need to subscribe to. You don't kind of just call it and get data instantly. You need to subscribe to it and get the data as it happens. So with that, if we go back here and actually we need to start this again, it's probably the hot reload thing that was actually going crazy. It looks like.
But I would also like to add, like, now, why the hell would we want to do this in the first place? To have this the observable and all of that stuff, and I think that's a really important concept in especially event sourcing, but also in a way to the event modeling. So I forgot to mention it, but one really important aspect of the event model is the aspect of time. Which is kind of central to the whole event modeling information system, and everything that happens in it goes from left to right on a timeline, and that translates really well to events and to the read models, and because we cannot get the state of a read model before the event has occurred. And so then we are kind of bound to the time aspect, but we can kind of use that in a really good way to provide good user a good user UX in the applications.
Yeah, and it also helps you because so when things are eventually consistent, pushing this to the client makes a lot of sense. So you don't, if you were to have like I'm going to perform an action, I'm going to wait till the data is there. That's kind of a resource hog as well. So instead, we're actually just enabling you to be reactive all the way through. So we actually know when things change. So why not just tell you when it changed? So it's asynchronous in nature all the way. So with this, I think since we already have data in the event store, so we should now be seeing something here. We should be seeing carts, and there is. So it has actually, by the virtue of me just restarting my process, it picked up the projection, automatically discovered it, registered it with Chronicle, and ran it. And the way it does this is that it's actually catching up. So it's seeing that, okay, this is a new projection. Okay, I need to start from the beginning and actually replay all the events that had occurred. So we put that in, and then it just starts catching up. And sure, it produced what we expected it to be producing. It's a cart with items and total price. Okay, there's a couple of properties there that's internal to typical used by Chronicle itself. So just ignore those. The items and total price and the objects are here. That's basically it. And what is kind of nice, so let's see what we did. So I mentioned something about well, we mentioned a lot about the observability. Let's actually look at that. So if we do something like this, and we have the what's it called, the empty GUID, right? So if we do something like this, and we produce another request here. So we do, actually, we do have that request open here, don't we? Already there. So let's say we add a 43 and it's a different SKU. You'll see that it will automatically get that. And you'll see that the total price was changed and yeah, it added that thing. And if we were to now do, yeah, let's test our rule, you'll see, hang on. And if we were to do another one, we should be, oh, it's a bad request. Why is it a bad request? No,
Oh,
maybe I did something wrong. Okay, I'm not going to dwell too much on that, really. So what we now have is a query. We have a command. We have a read model. So if we were to just recap a little bit, I will close all the windows. And let's see, we have our command. We have something that handles that command and appends an event. We have a rule, and we have a read model, and we have a rejection, and we have a query. So that's kind of an end-to-end. The thing that we want to do now is basically have a UI for this. So if we go back here and take a look at what we got so far, we created this, well, UI for doing this. So what we can then do is inside the same place as so we keep these vertical slices very cohesive, as you can see. So it's C# and TypeScript code side by side. So what we can go and do in this is, let's say we go and create a file called cart contents. And it's a React file. So we do like export const, and we do cart contents. Like so. Hang on. we do a return like this, and for now, nothing. Oh, I'm supposed to sleep now. Oh, cool. So what we can put in here is basically, so we're using open source library called Prime React, and we'll just pull in the data table for that. And what we do have is we have on the read model, remember that read model. So we can do for for the items, we want to take a look at the items. So what is the SKU and the price, right? So you want to bind it to the items and the price like that. And of course, we need to import the column. And yeah, we have actually, I can do that for you.
Yeah.
This is one of the things that we have, for instance, in Cratis fundamentals for JavaScript, is the GUID type. So as you see, Sindra has imported the getCart query, and we're just using it. So this is kind of it's a React hook that gives you the cart directly like this. And we can then start actually using the cart items. Actually, we need to do data.items like that. So our front end is very, very simple. We have a thing where we can actually do, let me just do this. So if we go to the app TSX, we have the sidebar. So we can add let's call it the cart. And there is this shopping like that. And we can then do a route that is the cart and implement the cart contents, get that component in here. And I think that should actually be it. That means if we go back here, we already have cart and we already have the data like expected. And we can also, if we want to, we could show that thing, I guess, if we wanted to, for the argument's sake, have a div with the total price, right? So we can do the like so. It actually listens to what I'm saying. So you should see the number there, right? So we can do even better. We can do like total price and do an H2.
Cool.
That didn't matter much, but yeah. So that's kind of how easy this is to work with. And as you can see, it's very programmatic. There's no fetching involved or anything like that. There's also the concept of a view model if you want to go down the path of separating your code into model and view model, MVVM. There's also support for that. And you can see that actually I'm not going to implement that here, but if you look at the catalog that we did, which is basically hard-coded, there is this with view model, and that gives you the catalog view model. And what we can do with the catalog view model, we have an IOC container here. So we have the Microsoft Syringe, which lets us take dependencies here. So one of the things that we could be doing is take the add item to cart as a dependency. And being TypeScript, we can just do this. And the could be actually just a call to command like this. So what we can then do is just call the command like so.
We're
Yeah,
doing it
sorry.
like
Yeah,
this.
you're absolutely right. I let the AI get the best of me.
Yeah.
So, and that would be the result. And we can actually then take a debugger here and see what's going on. If we go back to the catalog, we should now be able to see here and see the result from that. Error during server, something is wrong with the server. What could that be?
Response. Oh no.
Oh no, we have a bug in our software. That never happens in real life, does it? 405. Method not allowed. Oh, yeah, look, we're missing something. The ID of the cart.
Mm-hmm.
That's kind of important. So now we should be seeing something else. Yes, false. Validation results. What could this be? Number of items. You can only add 3 items to the cart. Yes, makes sense. So that is actually also coming to fruition. So we're not going to be able to actually add more items to this cart. This is kind of cool. I'm just looking at time, Sindra.
Yeah. Time is relative.
Time is relative. Time is of the essence. So I promised aggregate. Okay, we're going to be able to do that in t minus a couple of minutes, right?
Seconds, I think.
Second. So
Yeah.
what we can do, let's actually start here. So let's create a cart aggregate route. So let's move that to its own type now. And what we can do is just have a item and do this. We could optimize this to be just this. Right. That's the simplest thing that could possibly work. But I did mention something about cart created. So let's say we have an event called cart created. Doesn't need anything on it, just something to make it significant that we're actually creating a cart. And we only want to create the cart if we don't already have one. So one of the things that you can do with an aggregate route is basically go in and say is new. If it's new, we can apply cart created before we do add item to cart. So in our command handler, we would now not use the aggregate. Well, you've actually changed this. So we wouldn't be using the event log directly. We would be using the aggregate route factory. And basically inside our event handler, or sorry, command handler, we would be getting the cart based on the cart ID. And again, this is the event source ID that we're using. This is the unique identifier for a cart. And we would then be calling this method. And aggregates are part of a unit of work. So that's basically a transaction. So what happens is that we have an implicit hookup of transactions when it comes to being used in an HTTP context like this. So we will automatically create the unit of work for you. And whatever aggregate routes you're working with and whatever you're performing, it will treat that as a transaction, meaning if you call multiple aggregates and multiple methods on these aggregates, it will actually gather all these things as one transaction and say, okay, these are the events that needs to go together. So it'll look at that as the transaction scope, basically. So your command becomes your transaction scope. And that either has to go, so if one of them fails, all of them fails. So you will also be able to, you can get to that failure, but that failure will also bubble up into that command result if so happens. But you can also go and get it. You can go and get the current unit of work, and you can actually inspect the failures yourself. So with this, I think we should be able to actually run this again and have this going through an aggregate now instead. So if we are a little bit clever on the front end now, what we can do for our catalog, let's see. So on the view model, sorry, let's not use GUID empty, but actually GUID parse, and we'll give it a not an empty. I say I want to have a proper new GUID. So we should be able to now do the same thing. And now I have that debugger thing that I don't want to have anymore. But it returned a 400. That can't be good. Didn't I save? Yes, I did. But I need to refresh. Oh, there's a bad request. Why is this? Okay. I see that we're running out of time, so I'm not going to have time to actually go and debug this fully. But we can try it with the post here. And what we had is a raw JSON stew, and then price 42. Yeah, so that's our only 3 items. And if we go and do this, okay. Yeah, that's the thing. So our rule is actually missing something very critical, because now it's actually looking at all the events, but we need it to look at just per model. So this was a missing thing. So what we're basically saying is that this will be the model key, and the rules engine will pick up on that model key and use that automatically as a filter. So that means we need to reload this like this, and we should be good to go. And there we go. So that means also our UI should now work. If we refresh, at least. No. Okay, that is something completely different. I'm not going to dive into that. So I think that's kind of it, I think. I know this is kind of jam-packed, a lot of stuff going on in 1.5 hours. But kind of what we haven't actually touched on a lot of the building blocks that we actually have in Chronicle and Cratis universe or Cratis Stack. So, for instance, there's a lot more to support the dynamic consistency boundaries. We have things like constraints and other constructs to actually help you do that if you don't want to go down an aggregate route. And there's also but much more you can do with the projections. You can do one-to-one relationships. You can do much more complex stuff inside the child relationships, and you can have one-to-one within a child and all these kind of things. And also, we didn't touch on reducers at all. So that's also typically for as this would grow. projections will not cover all scenarios. So typical more complex scenarios might be well, hard or maybe not possible to express with projections. And we're not going to be expanding on that projection engine to the end of time to just accommodate all kind of functionality. We want it to be, well, have a certain, cover a certain need, maybe like 99% of the time. You'll be good with that. Reducers will give you more flexibility. And also, we didn't touch on reactors, which is also more flexibility. So, yeah, I think that's kind of it, I would say. So, yeah, I hope you enjoyed what you were seeing. And we will get back with more stuff. We have samples in the works. All of this will be pushed to GitHub, our sample repo. You'll find all the links on Cratis.io. And yeah, until next time, well, get in touch. We also have our Discord. So please join our Discord if you have questions. And let us know what you think. And if you have feedback, any good or bad, please come with it. And
Yeah,
we're here to help if there's any bugs. Any
yeah,
closing
and
remarks, Sindre?
yeah, I think that we'll be doing something similar to this again. Maybe not all of the not so much like a presentation, but more coding maybe, and more the live event modeling. Since I think that would be really fun to have like a different domain to work at, where we can show off more of the capabilities for the projections, for instance, and maybe getting into the reactors. Maybe we can even create some systems that have external API interactions and stuff like that to take advantage of.
Yeah.
And maybe also multi-tenancy. That would be cool.
Yeah, absolutely. Yeah, very good point. Okay, well, thanks everyone who's been watching and who's gonna watch this in the future. So until next time, see ya.
But
Bye bye.